Hello everyone, myself Dr. Senthil P, Diploma of Computer Engineering. So today's topic is software-defined networks versus traditional networks. So by this image, you can see the difference between two different traffic networks. That is the left side one, that is traditional network, and the right side one, that will be the future traffic network, right? So on left side one, like you can see traffic signals and a policeman who is signaling the vehicles. So there is not much automations there on traditional vehicular traffic. So on your right side, like you have uh, multiple vehicles, that is through air, by road, and you have multiple bridges. So the difference between these two is, like, consider these vehicles and the bridges and roads, right? So as the data and the mediums which transmit the data, right? So in this SDN network, here everything is automated actually, right? So compared to traditional network, there is manual intervention is applied there. So like, and the traffic which is transmitted, that is the data is transmitted, is very less, right? So by comparing this SDN, which is fully automated, right? So this images can, like, by viewing this, you can see uh, the practical example of traditional and SDN network, right? Yes. So moving on to next slide. So this is an overview of traditional network. Like we use the connecting devices such as switches, routers, right, and hubs. You have bridges. Commonly, we use switches and routers in traditional network. That is, switches operates in layer 2 and routers operate in layer 3, right? But these two devices like has the two major planes known as control plane or data plane. So here these control plane and data planes are coupled together, right? So because, so you have to take control decisions, and also you have to take forwarding decisions by its own in traditional network, right? So this control plane and data plane work together uh, to transmit the data from one switch to a switch, or one switch to a router, and vice versa, right? So then coming to packet forwarding technique, right? It follows hop by hop basis, with each node making forwarding decisions on its own. So what do you mean by hop by hop is, like you have to, like, jump device by device. Like the data has to jump from a switch to a router, then a router to a switch, or a router to a router. Then it has to pass multiple hops. That is, it has to jump multiple devices to reach the destination, right? So that is how a packet or a data is forwarded from a source to destination, right? So then coming to this configuration methods, like that is defined as box by box, right? So what do you mean by box by boxes? So the term box refers to a like a connecting device like a switch or a router, right? So what we do here is, in traditional network, we have to configure each and every device manually, right? So you have to connect each and every device, then you have to configure each and every device manually, right? So there is no automation at all. So box by box configuration is applied here, method is applied here. That is, if in case in a data center, if you have like 100 devices, like a switch or router, you take any device. If you are following a traditional network method, you have to connect to each and every device individually, then you have to configure it manually, right? So that is the term the box by box refers to, right? Then the troubleshooting method, yes, it was more complex. As the number of devices increases, the complexity will also increase, right? Yes, it is directly proportional to each other. That is the number of device and complexity in case of traditional network. Then the managing terms, like the managing networks includes a routine set of activities like backup, repeat configuration tasks, fulfillment of request, and keeping the lights on. That is, you have to follow a routine method to manage a traditional network. That is what it says, right? Then, so this image will show you a quick look how a traditional network is connected to internet. That is how your local network or a local area network is connected to internet, how the data is handled, right? So here, like I have given 4 steps actually. So the data comes from internet, the data enters into your local internet, local area network. That is the step number 1. So it will reach a DMZ zone, that is a demilitarized zone. So that will monitor the data continuously. So what are all the data arriving inside, so which will cross through the firewall, right? You all know what is a firewall, right? So firewall is a device which filters incoming and outgoing traffics, right? Yes. So then the step 2, once it reaches a DMZ, so this DMZ will have majorly 3 kind of servers, which will be a web server, email server, and a proxy server, right? So this web server, email server, and proxy server, which will be connected to a application server and database servers. So once the data reaches these any of these servers, so it will communicate either application server or a database server depending upon the requirement. Then this application or database server which will transfer the data back to the internal network, uh, where the user workstations, that is the end devices, or internal servers like the production server or a testing server, right? Whatever it might be, that are the internal servers there. So it will be transmitted, the application server and data server will transmit data to this end devices, right? From where this will be transmitted to the 4th step, final step will be the proxy server, right? So which will provide you security, that is for outbound data from the network to internet, right? So this was the process which will be followed on a traditional network. Yes. So we have seen until now, we have seen how a traditional network works. Now I will see about SDN, that is software defined network, right? So SDN separates the network's control, that is the brain, and forwarding plane. As we know, there are 2 planes, right? Control plane and data planes. So here in SDN, we have these 2 planes. Yes, but what we do here is, so we are going to separate this control plane and data plane, right? And provide a centralized view of distributed network for more efficient orchestration and automation of network services, right? So that is, here what you do is, by separating this network control plane and forwarding plane, you are going to orchestrate and automate the network process, right? Then the protocol used here is OpenFlow. The protocol is called as OpenFlow protocol, which is a standardized way of network where how it should run, how it should operate, how it should communicate between this control plane and data plane, right? This protocol, OpenFlow protocol, is responsible for this plane communication, interplane communication, right? So I have given a diagram here. That is, you can see this both control plane and data planes are separated, right? So OpenFlow will act as a API. The protocol will act as API. So interface, right? Act as interface between this control central plane and control plane and data plane, right? So why SDN? Why we need SDN? So as I have given here, the points are automation, scalability, multipathing, multi-tenancy, and network virtualization. That is, so automation, yes, every process is automated. So there is no manual intervention for any process to happen successfully. Then coming back to scalability, so like if you want to increase the resource, yes, that will be automated, the resource will be increased. Or if you want to scale down, the scale up is increasing, scale down is decreasing the resource, right? So if a resource is underutilized, yes, you can scale down using this automation process. Then multipathing, yes. So from a source to destination, like the data will be like split, and it will be transmitted across many paths, like through multiple networks, so that it can reach the destination. So there it will be like automated, then it will be like rearranged in the destination yet, right? Then multi-tenancy, that is multiple devices, yes, the flavors of devices we use here, right? So it has a huge scope. Even you can use a lower end switch efficiently in this SDN network. Yes, because why? Because we are separating this control plane and data plane, right? Then network virtualization. Yes, network virtualization is nothing but like you are going to like virtually divide the hardware resource into multiple software resources, that is multiple VMs, virtual machines, right? So on top of that virtual machines, yes, you can install the firmware, so which will act as a router or a switch, right? So these are some major things, so why we should go for SDN. Then benefits of SDN, programmable networks, intelligent and control centralized, network interaction with API via API, then vendor neutral architectures. That is programmable networks, yes, because of automation. Yes, how we achieve automation? By programming, right? Programming, giving conditions. So how it react if a condition is satisfied, how it should react if a condition is not satisfied. So this network can be programmed so that it can be automated successfully. Then it provides intelligent and control centralization. Thus, by programming, you give automation. If you do automation, yes, you achieve intelligence in the network, right? Then network interaction via API, yes. So these planes, these control planes and data planes will interact with each other using this programmability feature. Then vendor neutral architecture, that is we use open source thing here. Yes. So this will be the final slide of this session. Like there are two images, that is for one for traditional and one for SDN approach, right? So in traditional network, yes, you can see the brain, and there is the control plane that is called as brain, and this forwarding plane which is called as muscle in a body, right? So this both are coupled together, right? This not at all separated. In traditional network, these are attached together, that is in a single device. Each and every device will have its own control plane and data plane. So when coming back to this SDN approach, on your right side, you can see there is only one brain there, right? So only one brain, that means, so there will be a centralized controller that is achieved like by decoupling control plane and data plane of a device, right? So you are like decoupling the control plane and you are centralizing it, you are programming it, you are automating it to control the forward plane of a uh, forward plane of a network. Yes. So that's it for today. We will see on more session. Thank you.